Welcome to This Explainer. Okay, today we are tackling something absolutely massive. We're exploring an incredibly urgent issue of human survival, global economics, and resource management. And while our focus today is on a specific region, the stakes literally couldn't be more personal for all of us. How do we feed a growing world without destroying it? We're digging into a comprehensive analysis on developing sustainable agriculture in Pakistan, which is a region standing at this absolutely critical crossroads of population explosion and resource depletion. So get ready because the sheer scale of this challenge is fascinating. Right off the bat, I want to hook you with this number 8. Think of it kind of like a ticking clock. Right now, Pakistan's agricultural system feeds about 4 people per acre. But when that clock strikes the year 2050, it must figure out how to feed 8 people per acre. That's twice the population on the exact same land. And, as we'll see in a minute, they have to do it with rapidly dwindling resources. So, can they do it? Let's find out. Okay, let's dive right in. To really grasp this, we've got to look at the sheer scale of the sector. Agriculture is the absolute backbone of Pakistan. I mean, it provides a livelihood to 66% of the population. That's over 5 million households. It employs 44% of the workforce and makes up nearly 21% of the total GDP. Even their industrial output and exports are largely dependent on the raw materials produced by this exact sector. It is absolutely crucial. So, here's our roadmap for this explainer. First, Pakistan's agricultural backbone. Then, the water scarcity crisis. Moving on to stagnant yields and challenges. Next up, technology to the rescue. And finally, cultivating a sustainable future. All right, kicking things off with Section 1, Pakistan's agricultural backbone. We need to set the baseline here with this classic 1987 UN definition. Sustainable agriculture means meeting our present needs without compromising the ability of future generations to meet theirs. Makes sense, right? But right now, intensive farming, the injudicious use of chemical fertilizers, and just overexploiting groundwater, all of this is degrading the land. This current path is seriously risking future generations. We absolutely have to achieve intergenerational equity here. Now, what's really fascinating here is the sheer geographic potential of the land. Thanks to really diverse topography and climatic variations, there are more than 20 cropping patterns to find by these different agroecological zones. This means the potential to grow a massive variety of crops is 100% there. Yet there's the stubborn over-reliance on just 5 major crops: wheat, cotton, rice, maize, and sugarcane. It's like having a giant toolbox but only ever using a hammer. And this lack of crop rotation and diversification, it's physically degrading the soil. Which brings us to a ticking clock of pure urgency. Section 2, the water scarcity crisis. This is the part that really made me stop and think. Consider this jarring contrast. Pakistan only has a 30-day water storage capacity. 30 days. Compare that to 900 days in the USA, or even 90 days in neighboring India. The country is literally living on the razor's edge of a drought. And with surging industrial and municipal water demand cutting into surface water, the agricultural sector is left highly, highly vulnerable. Let's look at the math behind this chaotic water economy. And honestly, it's pretty staggering. There's a mean annual river flow of 140 million acre-feet, or MAF. But due to massive system losses, canal losses, and watercourse losses, an astonishing 49 MAF is lost before it even reaches the farm gate. That's a huge leak. Well, actually, scratch that. It's more like a massive hemorrhage in the system. To make up for this, farmers are pumping up 50 MAF from groundwater. This is a super dangerous overpumping situation because they are extracting water way faster than the earth can recharge it. And how exactly is that precious water being used? Enter what we can call the double jeopardy of current farming practices. Puddled rice is a prime example of this. It's incredibly water-intensive, basically wasting massive amounts of this super scarce resource while simultaneously pumping out unwanted methane greenhouse gases. It's a lose-lose. These outdated practices are literally draining the lifeblood of the entire agricultural system. So how does this build into our next compounding threat? Let's check out Section 3, Stagnant Yields and Challenges. Get this, over 60% of cultivated land is underperforming right now. The data shows that progressive, well-equipped farmers are getting up to 60% higher yields in sugarcane and over 40% higher in wheat and rice compared to the national average. Why the huge gap? Because the average small-scale farmers are trapped by systemic hurdles. They're struggling with unavailable quality seed, inappropriate sowing methods, rampant weeds, and they only have partial mechanization. And hey, this stagnation isn't just in crops, it's in livestock too. Picture a small pastoral farmer. Over 50% of dairying households own just 1 to 4 animals. And these native breeds, they are genetically built for pastoral survival, meaning they spend all their energy walking for miles in harsh weather just to fetch water and grass. They are not built for modern milk yield. Because of this lack of systematic breeding, Pakistan actually produces less milk from 70 million heads of livestock than the US does from just 9 million. That is wild. So we arrive at the million-dollar question, the ultimate pivot point of our explainer. How on earth do we feed twice as many people by 2050 using less water on degrading land with stagnant yields? All right, let's bring the energy back up because the answers do exist. Section 4, Technology to the Rescue. The experts in the source material lay out this holistic 7-point agenda. You can't just fix one thing. The solution requires tackling land and water productivity, climate change resilience, stagnant yields, crop diversification, and human elements like social disparity all at exactly the same time. It's like a giant puzzle. We need a framework for indigenous solutions that are completely driven by research and technology. And this, right here, this brilliantly illustrates what technology can do. Take a look at historical sugar beet yields in the U.S. High Plains. They were slowly climbing. But right after the introduction of Roundup Ready, which is a genetically modified cultivar, the yield absolutely skyrockets. It totally shatters the previous stagnant ceilings. It's a proven scientific tool to break those yield barriers. The meta-analysis of global data on genetically modified or GM crops over 15 years is just stunning. When properly regulated, biotechnology offers both an economic and environmental rescue. The source reports a 68% increase in farmer profitability, alongside a 39% reduction in pesticide costs. It also accounted for billions of kilograms in reduced greenhouse gas emissions. The data neutrally yet very emphatically points to biotech as a major key path forward. Bringing it all together in Section 5, Cultivating a Sustainable Future. How do policy and human action merge with this new technology? Because here's the reality, all this amazing tech, it's pretty much useless without institutional reforms to actually support the rural workforce. The macro-level policy shifts required include utilizing modern GIS data to redefine those agroecological zones we discussed earlier, which allows for highly specific precision agriculture. Crucially, the government must enforce water pricing and groundwater rights to stop that chaotic overpumping. We need high-efficiency irrigation systems and better information and communication technologies, stuff like mobile weather alerts and market data actually reaching the small farmers. I think this quote really hits the nail on the head. It perfectly summarizes the core thesis of our source material. Human survival, economic stability, and meeting those crucial sustainable development goals, they depend entirely on embracing agricultural innovation. It requires a long-term commitment to human capital, skill development, and strategic public policy. So we started this explainer with a ticking clock, and that is exactly where we're going to end. When the clock strikes 2050 and there are 8 people per acre looking to the soil for survival, will the right policies and innovations have been planted today to feed them tomorrow? It is a massive, massive global challenge, and the time to act is right now. Thanks so much for joining me for this explainer, and keep questioning how we shape our future.